There are a lot of new words, so just be warned, okay? You can go back and do that, or you can do it now, whatever. All right, let's start. A circle, you've heard that word before? Formal definition. You ready? A set of all points equidistant, you've heard that before, from a given point. So if you put a point here, and then you make another point here that's this far from that point, right? If you were to go all the way around that same distance from the center, there's an infinite number of points, and that's what forms a circle. That's just a picture of the definition. All the way around. Yeah? Equidistant from the center, from that point. Okay, radius is a segment whose endpoints are the center and any point on the circle. Try your best to draw a decent circle here.
That's a pretty good circle.
It's okay.
Mine's like a pole. Mine's a square. Just kidding.
Okay. Now, let's draw the radius. It's a segment whose endpoints are the center, so put a dot closest to the center, and any point on the circle. So we generally just draw it like this. Of course, it could go to any point on the circle, and that is your radius. You know that. All right? Now, chord. C-H-O-R-D is a segment whose endpoints are on a circle. So if I draw a line right here, it doesn't have to be, but so there's a segment whose endpoints are on the circle. That's a chord. A diameter fits the definition of a chord. It is a chord whose endpoints are on the circle. So if you extended this radius, that's a diameter, and that also could be called a chord because its endpoints are on the circle. Which one?
What's the difference between a chord and a diameter?
Nothing. A diameter is a chord. But a chord is not going all the way across. A chord can just go from any point, any 2 points on a circle. But a diameter has to go specifically twice the radius. Diameter has to be twice the radius. Okay? All right, a secant is a line that intersects a circle in 2 points. So 2 points. So I'm going to draw a secant here. Let's say it goes like this. Why did I draw something with arrows on the end? Because but the definition is a line, right? That goes forever, that intersects a circle in 2 points. So there's the 2 points. So that is called a secant. Oh, you've seen this next word.
Just kidding.
Tangent. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. So I could draw a line up here that only hits that circle. It's supposed to be just 1 spot there. And that's different from secant in that it only hits the circle in 1 spot. I'm visual. I need to draw pictures. I don't know if that helps or not, but it kind of helps a little bit. All right, we're going to work with these words and this particular theorem right here. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. That's a lot of words there. I can draw that for you right in this picture. It says right here, this line can only be considered tangent if it is perpendicular to the radius. Okay? So basically what that tells you is if they tell you this is a tangent line to this circle, you know that it forms a right angle to the radius. That's what that's saying. What?
I don't know. It just doesn't make sense because it's a circle and it doesn't make sense.
No, it doesn't. The radius is perpendicular to the tangent line. Yeah, just to the line, okay? All right. Tangent segments, this is supposed to be form. Oh, no, it is from a common external point are congruent. All right, let's draw what that means. So draw yourself just a little circle here. Little circle. If we have tangent segments from a common external point, so I'm going to put a point out here. And I'm going to draw a tangent segment here and a tangent segment here. So those both hit that circle in one spot.
Oh, it's like a bird. Sideways.
We know that these lines are perpendicular, okay? We also know, according to this theorem, that those segments are going to be what? Congruent. If they come from the same point outside of the circle, and they are both tangent to that circle, they are congruent to each other. So that's what we're going to kind of work with today. All right. Tell whether the line or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. Here's the important part right here. Tell whether the line or segment. You have to look at what's above the letters before you answer the question. It tells you whether it's a line or a segment, right? So here, segment DC is this piece right here. So what is that piece? That's just a radius, okay? Segment BD. Be careful. It's not a secant. It's a chord because they're talking about the segment, not the line, right? So this is a chord. See that if it had the arrows above it, that would be talking about the line, and then we would say it's a secant. All right, DE, what is DE? Diameter. Segment DE is the diameter. What? It's twice the radius. It is a chord also, but we can more specifically say it's the diameter. All right, line AE would be considered a what? A tangent, because we're talking about the whole line here. Yep. Cool? All right, turn it over. Tell how many common tangents the circles have and draw them. So again, a tangent hits a circle in one spot. So can we draw a line somewhere here that would hit both those circles in just one spot? We did this. One spot, one spot. There's one tangent line. Is there another place we could do that? Other side. Is there any more tangent lines in that drawing? No. So we would say two common tangents. Okay? All right, well, this next picture, can we draw those same two lines, basically? We can. That tangent line hits both those circles in one spot. We can do the other side as well. Oh, but there's more. Yeah, we could do a diagonal inside here. Look. We could do two diagonals. There's a tangent line. And then there's another one going the other way. So how many common tangents are there? 4.
There's 8.
We're not counting the intersection points. We're just counting the lines. Tangent is a line. Okay. All right. So this last one, what do you think? Yeah, we can do the same 2 on the outside. Oh, that one kind of missed, but I'll make a big dot there. And then there's another one. Where is it? Across the middle. Oh, that's way off too, but all right. 3 tangent lines. 3 common tangents. Okay? So now we're going to use the theorems to solve some stuff. In the diagram, segment AB is a radius of circle A. Is segment BC tangent to circle A? And explain. So if it's tangent, it's going to form a what? If it's tangent, yeah, this is going to be a right angle here, which means it forms a right triangle, which means it has to make what true? The Pythagorean theorem. Okay? So we have to check for a right triangle. Check for a right triangle using the Pythagorean theorem. Using the Pythagorean theorem. So is 25 squared plus 60 squared, I'm going to put a question mark there, equal to 67 squared?
I'm guessing yes, because it's an example.
This, I believe, is 4225. I did this quickly. No. And Paul, is this 4225? Pretty sure. And then this is 4489.
I called it.
So they are not equal.
I know.
No, because they're not perpendicular. It's not perpendicular to the radius. Okay, in the diagram, S is a point of tangency. Oh, what does that tell me? If they're saying it is a point of tangency, then I know what?
Right angle.
It forms a right angle, so it's a right triangle. Find the radius R of circle T. Okay, so again, if it's a right triangle, and I'm talking about side lengths, I can use the Pythagorean theorem.
I thought you said there was no triangle.
I'm sorry, they were here. Always, always, always. So, okay, these are my 2 legs right here. So I'm going to write R squared plus 48 squared.
Okay.
It's not too bad.
I'm guessing yes.
Equals, don't say just 36, because it's not just 36. It's R plus 36, all of that squared.
I didn't see it.
That's why you did the warm-up problem. So we're going to write R squared plus 2,304. Oh, just stay with me. And you got to FOIL this. It's not 36 squared, though. Well, the end is. R squared plus 72R plus 1296. That's FOILed. I FOILed it. R plus 36 times R plus 36. Oh, no, because it's not multiply. You can only distribute when it's multiply. Yep. So, cross these off. That's not so bad. If you were to subtract R squared, those would go away, right? And then you just have a simple algebra problem. This equals 1008, 72R. What's R equal?
14.
Right on. And that's what we had to find. We had to find R, so we are done. That's the radius. So, okay, in circle C, segment DA is tangent at a And DB is tangent at B. Oh, they're both tangent, and they're coming from the same
So they're
point.
congruent.
Yes, they're coming from the same point, which means that they are congruent. So we can just say both tangent. I'm going to write it down. So they are congruent. That's from 10.2. So then we can just do the simple algebra, which is Annie's favorite. Add 8 to both sides. 33 equals 6x. X equals 5.5.
Wait. You can say
Just